Let us start our class. We would like to explain a few words about the circulation. What is the circulation of? What do you mean by the circulation of fluid inside a boiler circuit? The flow of boiler in the circuit. There are two types of fluid is available or moving. One is water, another is steam, and within the boiler circuit, it is the movement or flow of these two fluids in different parts of the circuit is defined as the circulation of boiler circuit, circulation within circuit. It is an extremely important thing which we have to take, we have to manage according to the need yourself. And adequate circling, adequate circulation, adequate movement of fluid is extremely required to carry out the heat from the furnace. What exactly this liquid form of water or gaseous form of water, that is vapor, is doing inside the surface is, it is mostly the carrier of heat. It is carrying the heat from the furnace itself, get itself converted to steam, and then later it is impinged into the turbine blade, thereby at high pressure through the nozzle, so that turbine starts moving, and due to this high speed of the high velocity of the fluid itself on the turbine, at the expense of the movement of the turbine, its speed reduces and its power is thus converted to the turbine movement power. Now, then it is supposed to be sent to the condenser itself, which is being cooled by some natural or artificial means if necessary, and this water is vapor is converted into water, then goes back to the circuit again to absorb the heat from the furnace itself. So the circulation is caused. If the circulation is caused due to density preference, the boiler is said to have natural circulation. Means there is no pump or any other prime mover like this, which is pumping the boiler, pumping the material, pumping your fluid. Then only due to temperature and the density difference, they have higher the density of the fluid, especially the water, it will move towards the density destination, towards the less density fluid vapor. Then this boiler is said to have a natural circulation itself, and it is caused by a pump. It has forced, when it is forced, when it is being pumped or forced to move inside the circuit, and it is called controlled circulation itself. The downward the boiler circuits, the movement of the fluid inside the boiler, which can call it the circuit of the boiler itself. The boiler circuit can be designed for the maximum movement due to natural circulation like this, where it's the weight of the liquid water which is heavier than the steam itself, is being used by naturally to move the full flow of liquid water and water steam vapor system inside the system itself. A simple downcome or rise circuit is connected to a drum, and header is shown in the next page. I will go to the next page. It is like this. Hello, Bolo.
Good morning, sir.
Good morning. At least,
sir, I haven't been added yet, sir, into the LMS portal.
Hello.
Yes, sir.
हाँ, की बोल चुकी? क्या बोल रहा है?
अभी तक सर मुझे LMS में ऐड नहीं किया गया सर। 2 महीने हो गया। LMS पोर्टल सर, ये LMS पोर्टल कॉलेज वाला।
SMS फोल्डर तुम्हारा अटेंडेंस नहीं हो रहा है?
नो सर, 2 महीने हो गए सर, अभी तक मुझे किसी ने ऐड नहीं किया सर। आपको कितनी बार मैंने कहा?
But I think I've seen your attendance yesterday, but you were not in the class itself. Try to do it. At present, I can't.
I've talked to HOD, sir. He said he will talk to you, but I have no update on that, sir.
क्या बात कर रहा है अपन?
I don't know, sir, but I have talked to Ashish, sir.
When
he said talk to you about my enrollment, sir.
That's right. He told the right thing. What
Yes, sir.
you want to do your students? Okay, in LMS. Am I
Yes,
right?
sir.
Okay, but what the LMS portal is saying to you?
You cannot enroll yourself in this course.
You give me a message that I can see whether there is any problem with your enrollment. Okay, but I think I have seen your attendance system a few days before or even tomorrow, yesterday. Let me continue. Okay, we are wasting
Oh,
time. Uh, you send your name and email ID in the message. That I will try to see whether it can go inside. Okay.
so I have sent you many times, sir, on WhatsApp.
Then
My
give me
email, email
the
ID, and the screenshot
just,
of
just
that.
just a minute. Give them photo shot in the website. I mean in the WhatsApp itself. Okay, it can be
Okay,
shown
sir.
to the people concerned. And just write down clearly what is the problem. Now, question is there is a simple downcomer riser circuit for natural circulation. Connecting a drum and a header is shown here. The downcomer, which is insulated outside the furnace, and the riser is inside it. I am showing you the message now. Oh, sorry. Share. Now it is a natural circulation in a downcomer riser circuit. Why it is named like this? This circuit consists of the downcomer means a pipe which brings down the liquid water, and some of course maybe it is mixed with some amount of moisture inside. It's come down and goes to a header itself. Header, it is a place or a chamber where all the economize all the downcomer pipes may connected and accumulated all their all their fluids inside it, and it can be a small one meant for only one downcomer itself, but it is necessary in order to keep a storage, or what will we say, a tank for the fluid inside the downcomer, which can be used when there is a shortage in the line of the fluid. Now, what is here? It is This is the drum, and from here it is goes to the superheater. SH means superheater itself, and now this is the height of the particular downcomer itself. Here we are using the gravitational force, means the weight of the liquid, just for the movement of the uh, fluid inside the circuit itself. Through this downcomer pipe, it comes to the header itself, and by the pressure of the liquid water from the header, it goes inside the riser tube itself. Riser tube itself is inside a furnace wall. Means it is shown that this is a furnace wall is shown here. Means this portion of the pipe is went inside the furnace wall itself. With that, it is being heated by the fume of the furnace, and it is converted into the moisture itself. And by the pressure of this uh, heavier liquid water, this vapor is went up and goes inside the boiler drum itself. And from where the vapor goes to the superheater, and the next liquid portion, and it starts pushing for the next amount of vapor itself through the riser itself. From the header, which is here, you see water flows up along the riser, which partially boil with the fraction and bubble, then break into the steam drum itself. Actually, it cannot, it is, you see, as per the friction itself, here the portion of the riser inside this riser tube, a portion uh, here in the riser tube, the fluid is a mixture of water and moisture itself. This is the water condition, and these round points are known as the mixture itself, is the vapor itself. And you see, liquid is mostly up to this portion. This is mostly liquid water, and from here, after taking so much heat from here to here from the furnace, it is became more or less in the vaporous state, but not totally. It goes back, a portion of the liquid water keeps here, it start again made the circulation again by coming down, and the portion of the vapor will taken up from the top of the boiler drum and goes to the BD means the boiler drum, top of the boiler drum to the superheater means SH, that is superheater itself. This is one way of natural circulation itself. Always we are using the density of steam and water vapor mixture in the riser, so that the standard water in the downcomer and as the standard water is in the downcomer, as a result of this density difference, a circulation current is set up. So this is water, this is mixture of vapor and water, and this is the vapor itself. So itself, what is going on here is the due to the higher density of water, and as such, as higher density means higher weight, it is creating this natural circulation inside here. Now, feed water from the economizer enters the drum always, and saturated stream from the economizer it comes to inside the drum, and from the drum itself, it is saturated stream is supplied to the superheater, where it is heated to around 530 to 570 degrees centigrade. But it is input is a saturated stream, more or less around 100 degrees centigrade temperature. Now, pressure rate available for the, I'm going to the next page now, 16. Excellent. Okay. 60. Water is a pressure head available for the natural circulation is given by delta P, tender pressure, G into H, PD, rho into D, rho D into rho M, where H is the height of the riser, means inside the furnace itself, and rho D is the density of the saturated water in the downcomer, and rho M is the mean density of the steam water, steam water mixture in the riser itself. For simplicity, the mean density rho M means may be taken to be an arithmetic mean of the density of the bottom or top of the riser itself, okay? Or rho M, rho bottom plus rho bottom rho omega p divided by 2 itself, which is the density at the top of the riser. It is the density of the liquid vapor mixture at the bottom of the riser itself. So what we are getting here, the natural circulation, it requires a pressure for the movement of the fluid. That pressure difference, I mean the pressure difference for the movement of the fluid, and it is being given by this formula. It is G acceleration due to gravity multiplied by the height. Height is the height of the riser itself, and it is multiplied by the rho D, the density of saturated water in the downcomer itself, which is coming down, and rho M is the mean density of the mean water and mean water and steam mixture in the riser itself. And how will you get the mean density? You will get the average from density at the bottom, density of the fluid at the bottom of the riser, and density of the fluid at the top of the riser, and make a mean of it, means divided it by 2. Now, rho bottom is equal to rho D, means at the bottom of the riser, the density is equal to the density of the water at the downcomer, and rho omega p is the density at the top portion of the riser itself, or which is equal to 1 by specific volume, 1 by VWP, where VW is the specific volume, and or 1 second, and VWP is equal to VT. VWP is the specific volume of the water and pressure vapor, water and vapor, equal to Vt plus xwp into Vg, where xwp is quality of the mixture, or the mixture, the ratio of the vapor and water ratio at the top of the riser, and often referred to as the top dryness fraction, is also defined as top dryness fraction, or the ratio of ratio of vapor to water mixture itself. Uh, the maximum height of the furnace itself, that is h, in given the earlier equation, is generally fixed by the load rate of delivering, fixed on the rate of delivering the fuel and load release work. The rate of delivering of fuel and the heat release rate. How much feet means maximum height is directly fixed by how much the fuel is being loaded per minute or per second, as well as how much is released, heat is released from it per kg per second. For a custom, H is proportional to rho d minus rho m, means uh, rho, rho d is the density of the water, density of the mixture at the down downcomer, and rho m is density of the mixture, when it is circulated between water and fluid itself, when it is mixed with water and vapor itself. Higher the density difference, the more will the pressure head available for natural circulation. Means uh, higher this value of the liquid water, it will create more, higher the value of density of the liquid water, it will create more pressure difference to have better natural circulation. However, the density differential, as pressure increases, it is also increases. As pressure goes up, the density differential means difference between these two densities, that from down corner, that from the mixture, it's goes up, and that became this difference in specific volume, Vg minus Vf, Vg for gas specific volume with per weight per unit volume, divided minus weight per unit volume of the gaseous fluid, minus weight from the per unit volume from the fluid itself, or the difference in the density rho f minus rho g of saturated liquid and saturated vapor decreases with increase in pressure. So the difference in density of saturated liquid and saturated vapor is decreases with increase in pressure. So difference this difference goes up, reduces reduces to a certain, up to a certain level itself. So it is not helping you much about creating the better circulation itself. Now at the critical pressure, where specific volume of gas is equal to specific volume of the fluid, and density of gas is equal to density of fluid, and there can be no natural circulation at all. So the critical, generally the mostly today's boilers are operated at critical pressure, because there is no vapor and water mixture. Vapor is immediately transferred to the immediately transferred to the fluid, converted to the gaseous system, where it is kept in the natural critical pressure itself. So there cannot be any natural circulation, because there is no much difference between density, and there is no much difference in the no differential pressure is created. Now, risers here are installed. The risers here are installed all around the four walls of the furnace, acts as cooling, as cooling or water wall, and carry the heat from the furnace all itself. The risers are the rods which is creating the circulation, and which is where this vapor is liquid water is being converted to vapor. It is installed all around the four walls of the furnace. So furnace walls is filled up with risers water and risers pipes, and it is also carrying away heat of the furnace the same rate at which heat is released. None and water, and it acts as a cooling or water wall. You can say around the walls of the furnace, that is water wall is created, or cooling of the furnace is created, because the heat is being carried out from the furnace itself at the same rate at which heat is being released. 16 এটা বলেছে 16 17 now it is the forced circulation system itself. In earlier picture was given as natural circulation, but this picture is given as the forced circulation itself. Uh, and carrier action. What just have told you, all the furnace walls, all 4 walls of the furnace are being occupied by the pipes of the risers, which acts as the cooler of the furnace by taking away the heat generated inside the furnace to increase the volume change, increase the phase change of the liquid water itself, and also it acts as like this. The amount of released by burning the fuel, there it takes away all the heat almost without any wastage of it. Although the furnace is properly insulated, but there is nothing like perfect insulation. So as much as possible, the heat is being taken to generate heat generated is taken out of the riser walls inside the fluid itself. In this reason, adequate circulation must be provided in the cycle. So where higher, better the circulation, better the movement of the fluid, it will move more and more amount of heat, and so that heat will not be wasted because we are burning costly fuel inside the furnace wall itself. Now, what happens? Uh, for this reason, adequate circulation must be provided in the circuit itself. So, how can you make this adequate circulation? If the circulation is not adequate, rate at which heat is being carried away will be less than the rate at which the heat is released. So, there is two different terms. One is rate of heat release. What is rate of heat carrying away? The the rate of release should be more or less equal to the rate of heat carrying away, because in order to stop the wastage of the unnecessary wastage of the fuel itself. Now, what happens uh, if the circulation is not adequate? This process may not be done. So, at the rate of which heat is being carried away will be less than the heat of release, and the difference will stored in the metal of the riser wall itself and leading to their overall overheating, ultimately repairing. And take, when the tube temperature exceeds the melting point of the tube metal itself. So what is going on here? If the rate is not sufficient to carry out the heat away from the furnace, furnace will make the all these riser rods, riser pipes are heated to a much more than their capability of taking, and the heat leading to their overheating and ultimate repairing, rupture and repairing when the tube temperature exceeds the melting point of the metal itself. It may so happen that melting point of the metal after prolonged heating from the furnace itself may exceeds. Then that will make this all these tubes leakage, and it requires shutdown of the plant and costly and time-consuming replacement of this pipe wall itself. So we have to ensure proper boiler pressure. Now, if the boiler pressure is greater than 30 bars, the downcomers are placed outside the furnace itself so as to secure more density difference for natural circulation. Always here you see this is the outside the furnace, this is inside the furnace, this is the furnace wall itself, and in an earlier sketch as well as in this sketch we are having the look that downcomer is placed or situated outside the furnace itself. But and both downcomers are risers sometimes placed inside the furnace are heated, and the net density difference will be less. But in that case, pressures for less pressure, both are in space as both are placed inside the riser. With the riser installed in the boiler zone, the tubes which are heated more will act as riser, and tubes which are heated less acts as a downcomer itself. So what happens here? Sorry. When the boiler pressure is greater than 30 bars, what happens? Downcomers sometimes placed outside the furnace so that secure more density difference, create more density difference is because keeping it outside, the liquid water is flowing inside the downcomer portion of the circuit itself. But it may so happen both downcomers and risers are placed in the furnace itself and both are heated at a time with the more or less at the same amount of heat is being absorbed by both of them or same temperature is being raised inside the fluid of both the tubes carrying tubes, and this density difference will be very less and it will not ensure the movement, so you have to make certain artificial means of running it. However, if pressure less than both are placed inside with the riser installed in the boiler zone and the tubes which are heated more will act as the risers and tubes which are heated less than acts as a downcomer itself. So it is an opposite type of movement because as both are placed inside the surface, but riser portion installed in the hotter zone, the tubes are more heated and acts as a tubes which are heated more will act as a riser and tubes are heated less it acts as economizer. So what we are doing here, where both full riser downcomer assembly is placed inside the boiler, but downcomer is more or less placed inside near the wall and the riser portion is placed more or less at the center of the furnace where the heat is maximum. So there will the in between, although they are heat different, pressure difference is less, but the cooler portion placed inside the furnace is known as downcomer itself, and hotter portion placed into the hotter area of the furnace is called the riser itself. Now, if the pressure of the steam exceeds 180 bars, what happens? The density difference rho I and rho G, that natural circulation cannot be relied upon. So we cannot say that the density difference, that is the difference between the gas and mixture, the gas difference between the gas and mixture, the natural circulation cannot be relied upon because the difference is very less. Where both are sometimes placed inside the furnace, though, although they are heated in a different amount, but the difference is not that big to create a natural circulation. Natural circulation, then so we have to use the forced circulation, and forced circulation is used where we are supposed to use a pump circulates our saturated water through all the risers around the furnace wall itself. So here we are now ultimately going through from natural to forced circulation itself. Now just 1 second. Now what happens? The circulation, it stops here. Go by the shade to Now there is a term known as defined as circulation ratio or CR used in this connection, and it is defined as circulation ratio is the flow rate of saturated water in downcomers and flow rate of steam released from the divided by the flow rate of steam released from the drum itself. The flow, what is the amount of, what is the rate of flow, rate of movement in say meter per second, centimeter per second of saturated water in the downcomer itself. But it is saturated means it is nearly near in the boiling point and it fully saturated with vapor. But it is carrying the maximum vapor which it can carry under the same pressure itself. When higher the pressure, more vapor will be carried itself. Now, the flow rate of saturated water then in downcomers is divided by the flow rate of steam released from the drum itself. So what will be the flow rate of steam coming out of the drum? That is one point, means from the drum, what is the amount of steam we are sending to superheater is one of the issue, and flow rate should be supposed to be more than the flow rate of saturated water in the downcomer itself due to the action of pump itself, and refers to the amount of saturated water to be circulated through the downcomer's riser circuit per kg of steam released from the drum. So it is very clear. It is the amount of circulation of water is being circulated inside this full circuit per kg of steam released from the drum itself. Therefore, Cr is equal to m divided by mg, where m is the rate of a fluid plus the mixture itself, where m is equal to mi plus m1, where m mass of saturated water flowing through the downcomers and riser circuit during a certain time, and mass of the where m is the mass of saturated water flowing through the downcomer and riser circuit during a certain time, and mg is the mass of steam released from the drum during the same time. So m1 is here m minus mg, that is m1 is here m minus mg, and which is equal to the mass of the liquid saturated at the riser exit, m1 mg. ठीक है. Where mass m1 mg is the mass of the steam released from the gas, which is given here. m1 is the uh, mass of the liquid water at the riser circuit itself. m1 is equal to m. What I have shown here, mg plus m1 divided by mg. What is, or 1 divided by mg plus m1, and it's equal to 1 by TDF, where m is the mass of the where m mass of the saturated water flowing through the downcomer riser circuit through the certain time, mg the mass of the gas released. So mg minus m1, m1 is the mass minus mg, total mass of the liquid water saturated at the riser exit. TDF is the top dryness factor, that is the quality of liquid vapor before this being the amount of the liquid vapor being discharged from the riser to the drum itself. The quality of the liquid vapor mixture discharged from the riser to the drum itself depends like this. The top dryness fraction is given by this formula itself, and downcomers are fewer in number and bigger in diameter, whereas risers are more in number and smaller in diameter, because downcomers are made to make the water fall by gravity. So yet its uh, number is increased so that more liquid water is coming down, and thus forcing the natural circulation through the header itself. Then the bigger intermediate loss, and bigger the intermediate, less the pressure drop due to fraction. Bigger in diameter, less the pressure drop due to friction itself. So hence the pressure drop is inversely proportional to the tube diameter itself. So if diameter is higher, then it is less the pressure drop is due to friction, because more volume of air, fluid, vapor gas fluid is supposed to go inside it, and since pressure drop is inversely proportional to the tube diameter, the delta P or pressure drop or pressure gradient, F into L divided by D into rho into V square by 2. So the where rho is the density, V is the velocity, and F is the fraction, L is the length of the tube, and D is the diameter of the tube. So the downcomers are made bigger in diameter, which may vary from 150 millimeter to 200 millimeter or even higher. Now, what is MF? Where MF is equal to N pi by 4 D square into Pi into V, where MI, mass flow of saturated water in the downcomer, and N, total number of tubes here, and D is the diameter of the downcomer, not newcomer or downcomer, and M, rho I, the density of saturated water at the bottom of the bottom drum pressure, rho I saturated of the um, density of the saturated water at the bottom drum pressure, and kg per cubic meter, V, average velocity of water in downcomer. The circulation velocity depends on the circulation ratio in the tube and may vary from, uh, just writing down again, MF N, number of tubes, pi by 4, D is the diameter of the tube, Pi, where rho I is the density of the saturated water at the boiler drum, and pressure, V is the average velocity of water in the downcomer itself, and so in meter per second. So V is the pressure, average velocity of water. P is rho is the mixture density of the saturated water in the drum itself. D is the diameter of the diameter of the downcomer. N is the number of pipes in the number of tubes kept in the diameter. So mass of fluid is thus mass of fluid flowing is thus given by the diameter with the cross section area of the newcomer pipes multiplied by the number of pipes used, with total cross section area multiplied by the velocity of movement, circulation velocity of movement. So it is a volume rate of movement. It is it is being multiplied by the density of the pressure saturated water vapor mixture itself. Thus, it becomes the amount of mass flow rate of saturated water in the environment in kg per second. Generally, the average circulation velocity depends on the circulation ratio and may generally vary from 0.4 to 1.4 meter per second, depending on the capacity itself. Now, if the number of downcomers required can be estimated from the above equation, it can be 6.5 or as high as 20. Now, the number of downcomers can be estimated from the above equation. So all the means what if you have to estimate the number n, what is the number of downcomer tube? It can be 6.8, 6 to 8, or as high as 20 even. Again, the density of the density depends on the, again, depending on the capacity of the steam generator. Now what is showing here is the nucleate or filler boiling in Rider's UV cell. Nucleate and film boiling, nucleate and film boiling in the riser tube itself. What you see here, the tube itself is full of water, and the bubbles inside, bubbles of the vapor bubbles are fully poured inside it. The Q is the amount of heat is flowing from the furnace to through the wall of the riser into this water vapor mixture, and the surface blanketed by the bubble itself. In the full circuit is totally blanketed, means covered by the steam bubbles. So that is Q1 minus Q2, the delta U with M into E into delta T, means Q1 is the surrounding temperature, Qt is the surrounding heat, Qt is the temperature coming out, temperature of the riser at the end of the riser itself. So difference in heat, that is when the amount of heat absorbed by this riser itself is equal to delta U, or delta internal change in internal energy is equal to mc into delta T. M is the mass and delta T is the difference in temperature. mc and delta T itself. mc is the mass and difference delta T is the difference in temperature. And the nucleate steam bubbles have nucleate and film bubbles in a riser tubes. And another form of rising is like this. Film bubble may not be like this small bubble particles like here, like here, but a big bubbles like here, also here, here. Here, this portion is a liquid core, and steam the liquid core. This portion become the liquid water itself, which is at the top of the riser itself. The riser now absorbs heat from the furnace. For the same total cross-section area, smaller the diameter, the larger is the surface area exposed to hot gas for riser temperature. So here what we are doing, now this riser, the function of the riser is to absorb heat from the furnace. For the same total cross-sectional area, the smaller the diameter, the larger is the surface area exposed to hot water, hot gas for heat transfer. Therefore, the risers are of smaller diameter 62.5 to 76.5 millimeter, and larger in diameter compared to downcomer itself. Now, the larger the furnace surface are exposed to water jet, riser absorbs the heat, and for the same total cross-sectional, the smaller the diameter, the larger amount of surface are exposed to hot gases for heat transfer, because uh, therefore the risers are of smaller diameter 62.5 to 76.5 millimeter, and larger in diameter compared to the diameter compared to the downcomer itself. So downcomers are supposed to have higher diameter and risers comparatively less diameter. It is required to nucleate boiling should occur in each riser tube, and a film boiling is avoided. The nucleate boiling means only film boiling means it is forms a film of vapor around the surface of the tube itself, and nucleate boiling is a particular portion, total vapor is accumulated in a particular area. So so it is better to have the nucleate boiling than to each riser tube, and film boiling is supposed to avoid it, because film will not allow to transfer of heat from the furnace to riser liquid itself. Too much streaming and less circulation ratio in a riser may cause a departure from nucleate boiling itself. And an asset of film boiling recently. And recently, the water tubes are in high heat. Recently, the water tubes in high heat absorbing area of furnace are now provided with internal twister and sprays which will break the vapor film and retard the onset of DBN, as in figure in early pages. Recently, the water tubes in high heat absorbing area of the furnace are less provided with internal twisters and the springs which breaks the vapor film and return to the onset of DNV. So first of all, here what we are saying, the nucleate boiling and film boiling. Film boiling is a film of